Hello, I'm Abigail Hovorka. My research is the SI-RAFT synthesis of polymethyl acrylate grafted gold nanorods. This is from the NSF REU I did this summer at Cleveland State University, collaborating with Case Western Reserve University. First, I'd like to thank the collaborators on this project, Nahal and Dr. Hoare from Case Western Reserve University, Andrew from St. Vincent College, as well as Patrick and Dr. Streletsky from Cleveland State University. So to give an overview of this project, grafted polymers can be used to reduce energy consumption, control the dispersion of nanoparticles, and even alter the mechanical properties and behavior of materials. So while much is known about the conformation and relaxation dynamics of polymer grafted on both planar and spherical surfaces, we know very little about these properties for anisotropic shapes like nanorods. So the actual goal of this project was to graft polymethyl acrylate, or PMA, from the surface of gold nanorods in a surface-initiated reversible addition fragmentation chain transfer, or SI-RAFT, polymerization process using functionalized chain transfer agents to control grafting density. We also wanted to measure translational and rotational diffusion coefficients of the PMA grafted rods using depolarized dynamic light scattering, or DDLS, to determine their dimensions. Additionally, we wanted to establish an SI-RAFT method with the potential for future applications. So the main part of my summer research was the SI-RAFT polymerization process itself. So this summer we are working on the grafting from approach as shown here. I broke this grafting from approach up into 4 parts, starting with the ligand exchange. So here our rods come coated in a surfactant called CTAB that helps them keep their rod-like shape. So we need to remove that CTAB and replace it with our chain transfer agent. Once we have that, when our monomer comes into contact with these chain transfer agent covered gold nanorods, we're able to actually grow polymer right from the surface of the rods. So after introducing that monomer, that solution is kept under a blue LED for about 16 hours, and then we're left with our SI-PMA gold nanorods. This sample then undergoes 2 rounds of purification. The first round with hexane to remove any unreacted monomer, and the second round with acetone and water to remove free polymer so that our solution is just our polymer grafted nanorods dispersed in THF. So to get a visual of what our polymer grafted nanorods look like, we can look at these SEM images taken by Andrew. So A and B shows polymer on the end of a gold nanorod, and then C and D shows kind of a zoomed out view of the polymer itself. This other picture in the corner here shows what the bare gold nanorods look like, and this is what was taken for SEM imaging to determine the dimensions that way for our bare rods. Many forms of analysis were performed on our polymer grafted nanorods sample to confirm the presence of PMA on the rods. So here we have proton NMR, and we can see this characteristic peak for our pure sample at about 2.3 ppm. This is characteristic for PMA, so this is a great sign that we have PMA on our rods. Additionally, and similarly, for FTIR, our pure sample, here we have a characteristic peak at about 1735. This is due to carbonyl stretching, and it is characteristic for PMA. We also performed TGA on our sample, so this allowed us to find the mass of the PMA in our sample and therefore the grafting density. This grafting density was about 0.6 or 0.69 depending on whether we use the bare nanorod's dimensions from SEM imaging or from small angle neutron scattering, which was taken years prior by Dr. Hoare. DDLS was also performed on our polymer grafted nanorod samples, and this allowed us to determine the dimensions of the rods. So from the VV and VH correlation functions, we calculated the translational and rotational diffusion coefficients. These coefficients allowed us to calculate the dimensions of the grafted rods. So up here in this table, we can see the dimensions of our grafted and our ungrafted rods. We can see that the dimensions of the grafted rods are much larger than the dimensions of the bare rods, which also confirms the polymer layer on the grafted sample. With the dimensions of both the bare and the grafted rods, we were able to calculate the brush height of the polymer on the grafted rods. Comparing these brush height values to previously established models for polymer grafted on spherical and planar surfaces, we can see that the preliminary DDLS results yield a PMA brush height comparable with the theoretical prediction for a polymer attached to a spherical rather than a planar surface. Additionally, we successfully developed an SI-RAFT method which can be used for tests involving gold nanorods of different aspect ratios, grafting with different molecular weights, and even grafting with thermal-responsive polymers. Thank you.